This is the funnest part when you watch the numbers go down.
I feel this starts moving up.
Yes. Good morning, good afternoon, everyone. Welcome to another episode where we'll talk about interesting data and Lakehouse topics. Today, we're here with Bartosz from waitingforcode.com, a freelance data engineer, as well as a prolific member of the larger Delta and Lakehouse ecosystem community. Bartosz and I met a couple of times, so I know there's exciting things ahead. Today, we'll be diving into kind of what happens after you did the simple ingest. So how do you create an open Lakehouse architecture, specifically the data engineering, data processing parts of it, and make it into something productive, something useful that can support your business. So Bartosz, very happy to have you here. Welcome. I don't know if you want to say a couple of words, and then we're excited to dive into to design patterns for the open Lakehouse.
Yes, thank you, Robert. I'm excited too. So let's get started. My name is Bartosz. I'm a freelance data engineer, specialized in Apache Spark, Databricks, Delta Lake, and recently in stream processing as well. So, Robert, thank you for the introduction. I'm also blogging, so you can read me on waitingforcode.com, or last year I published this data engineering design patterns book at O'Reilly that inspired this session and a few others talk I gave in the past. So let's see what's inside. This is kind of simplified vision for, I think, data engineering projects. You start by acquiring some data, later you build on top of that, and you expose to your end users, respecting all the business requirements. And I think that as an engineers, we are always excited by this first acquire step, because it's about the data, it's about technology, maybe even so legacy databases that may be exciting and challenging to integrate. And you talk with your peers, you learn stuff, so that's so great. However, your end users will mostly judge you for what you expose. So as you can see, there is kind of a distance between expose and acquire, and probably they will not even notice all the effort you put into acquiring the data if you did things wrong in the build part. So they will judge you by this central piece, and that's the part we are going to focus today. And we're trying to answer a few questions with some kind of ready-to-use patterns or blueprints, and whatever you call it. They are here to simplify your life and mine too. So we are talking about the patterns, and to get a better idea on what problem we are going to solve, let's suppose we have a simple ETL job where we have an Apache Spark reading a delta table and writing another delta table. And despite this simplicity, there are some questions you may be asking yourself, like, for example, assuming you are processing an incremental view of users' activity, you would like to build a final final state for each user's activity. So the first question is how to deal with that kind of stuff when it's batch, right? Because the data is there upfront before you run the processing, but the data is not complete for a specific user. It's complete for the batch, but it's not complete for the user. Another question is more to ensure that you start the job in good conditions. So you start it whenever you have all the data required for processing, that you don't miss files, for example, or you don't miss partitions. So this is that kind of pre-requirements part. On the left, on the right, you start writing the data to your output, so doing this exposed job. And the first question to ask how to guarantee there is no duplicates, because duplicates are very bad for you and for your consumers. They can lead to some crazy stuff like with snowball effects, downstream pipelines consuming your duplicates, generating other duplicates. They can go really crazy. And how to contextualize your data, because you will probably run into bugs on production because of many things like human mistakes or wrong prompts, whatever. And you would like to know more on how a particular batch of data was generated so that you can isolate and understand the issue way better. And finally, there's also kind of constraint-based question, how to guarantee that each row respects what you defined for this for the format and also for the expected values in each field. So these are the questions, 5 questions. There are probably more questions you can ask yourself, but we have only 1 hour, and I will not probably be able to talk more than 1 hour because I'm very shy. So
I feel like each of those questions you could kind of spend an hour on, yeah. But we'll do the compressed version today, yeah.
exactly. So these are the answers for this incremental processing. You can deal with you can consider it as a sessionization problem and solve either with the stateful sessionizer or incremental sessionizer. For ensuring the requirements, there is another pattern, which is the audit write, audit publish. You will see the little variation of what you can see in other places. For the left part, we have the metadata decorator to know much more about your processing and the outcome. You have the merger, which is a very simple approach to deduplicate your records. And finally, you have the constraint enforcer pattern to ensure that the data you generate is correct semantically and also from the data business standpoint. So let's deep dive into them, starting with this audit write, audit publish pattern. I didn't invent it from scratch. It was inspired by some work did in the past by the community, especially by Michel Ufort from Netflix in 2017, who explained how they do data quality validation and all this kind of ensuring you are writing good stuff, valid stuff from the business meaning at Netflix and at scale. The talk is still online, so you can take a look and watch it. And I just extended this write audit publish with an additional audit step in the beginning that targets mostly your requirements for starting the processing. You can consider it a bit like a readiness flag, where you verify, of course, obvious things like whether the table is not empty, whether, for example, if you're doing some weekly based processing and you have 1 file per day, what you can verify that all the 7 files are present for processing, for example. You can also validate the freshness if you are not expecting to, if you're expecting to have data coming like every 10 minutes and you don't have it for 1 hour, maybe it's not worth you running the processing because it will just cost you money. And finally, also when you are doing partition-based processing, you can verify whether the next partition is created and start working on the previous one at this moment. So these are kind of guides, requirements for starting the processing. Later you have the right part, which is your data processing logic. And the second audit that I left from Michel's Michel's pattern is verification of the transformed data with your business rules like field emptiness, data state completeness. Like, for example, you could detect too aggressive filters with that whatever bugs came to your mind. And finally, there is this publish step where you take data from either physical or temporary table and you load it to your final destination. So there are currently 2 flavors for this this pattern. Later, either with data materialization, with the 1 table between the write and the second audit. Is good because it can help you. It enables you to investigate any issues you have when the pipeline fails because of some data quality rules. You can investigate it later, but it will materialize the data. It will write it to some object storage, so it will obviously slower than the second approach with the in-flight validation, where you generally do some persist on data frame and execute your rules. And besides, you can also implement a different approach to that. So still have this audit step, but do not consider it at a blocking point. And instead of writing all or nothing, just to split your writing part into two and publish all valid records to your customers and publish the invalid one to the quarantine tables, or you can call it also the letter table as well. And thankfully for you, there are two great open source community frameworks that are there to support you in this task: Spark Expectations by Nike and DXQ by Databricks Labs. They are pretty well integrated with Apache Spark Databricks platform as well. So yeah, there is no reason to not use them, or not, at least to not try.
Yeah, this is not trivial, right? So not reinventing the wheel is often a good choice.
Exactly.
If there's validated and proven stuff out there.
And yeah, it's also a good reason, because people often think that it will take weeks to set up something, and here with the frameworks, like not instantaneous, but it takes maybe days just to discover stuff, and it will not be blocking for business, I think, to spend these days to just to try and maybe have a better resilience in the generated data sets.
And so, I mean, we're talking about production deployments, right? So, and if there's one thing I learned is that in production, you'll see edge cases and all this kind of nasty stuff that doesn't happen in your test environment. So weeks is probably month if you want to cover all the test cases and have seen all of this, right?
Exactly. Yeah. So let's get back to the presentation, because I'm going to be disturbed. I will not be complete in time this one. So the stateful sessionizer is the second set of patterns to address this continuously coming data problem, where one activity can spread across many time boundaries, if I can say that way. And the problem we are going to solve is how to build the final state despite this boundary based activity like sessions. So the first one is the incremental sessionizer that you can run daily with batch processing and leverage a Delta Lake table to store all the pending states, so all the activities that are not completed in the given execution. For example, if you start watching a series at 11 p.m. and you end at 2 a.m. the next day, typically it will be the activity you will store in this pending state Delta Lake table, and combine it with, tomorrow when your job will run for all the data, all the new data. So you can facilitate your life here if you use partitioning. So yeah, with some patterns like fast metadata cleaner that I will briefly mention later, you can clean the partitions at restarting your job without having to do any manual operation. It's just a task to include in your data orchestration layer. So that's the first approach. And in code, it looks like this. So we have a Spark job where the processing logic is part of the for each batch sync, where you can see the pending state combined with the new data. And the iteration is represented here as available now trigger. So I mentioned partitions, so typically you can do it batch, but here is a kind of nice trick I like, and I learned a few years ago, I think from Scott, on this trigger available now, because it gives you the streaming semantics, like storing the checkpoint data. You don't need to worry. You don't need to write custom code to remember when you stop the processing. It gives you this streaming API, so you will see later how use it to solve the sessionizer problem as well. And third, thanks to this for each batch, that thing that I'm using here, it gives you also a possibility to use batch abstraction of the data frame. So it's like Swiss knife, but very powerful. And an alternative approach is for the stateful sessionizer, where the state is fully managed by Apache Spark in this case, and stored kind of locally in memory. So it's checkpointed, of course, for fault tolerance, but Spark has a faster access to it. It doesn't need to do any network request to reach objects from S3 or from blob storage. And here the implementation is a bit different, because we are using the stateful API, like apply in pandas with state or transform with state, which is the new one in Spark 4. And we are also having this trigger available now just to simulate this incremental processing, because very often this sessionization will not be required to generate immediate output unless you're doing some maybe recommendation project. So often you'll be fine to do it 1 hour or every 1 day for the sake of simplicity also. Because I'm digressing because you triggered me out, but sessions.
Yes, there's a lot of potential tangents here we could go on to.
Exactly. Yes, stream processing is exciting, but for me, it's still much easier to do things in batch. So yes, I close my parenthesis and go to the next pattern. And among big differences is this state storage, like external storage for the incremental, where you rely on a delta table, versus state local storage implemented as RocksDB or HashMap, Java HashMap, but RocksDB is much more performant for that. On the other hand, you have more flexibility for the incremental storage. It's queryable much more easier with warehouse endpoints or when you have an ad hoc framework, even outside of Spark. You can probably query Parquet files or Delta table with Flink as well. On the other hand, stateful sessionizer requires less implementation effort on your side, for at least for this state management. On the other hand, you must be aware that under the hood, it will use the number of shuffle partitions, so you will not be able to change them on runtime. So when you run a streaming job in Spark, it remembers the shuffle partitions in the checkpoint, and it uses the checkpointed value each time you restart the job. So it will be much harder. You will probably need to do some kind of state migration with the initial data state, initial state parameter in the transform with state. So it's much more challenging later to scale. And it's also much more harder to query, even though there is state reader API, but it's still less convenient than writing a SQL query, right? So this is for the sessionization. Now we're addressing the part of exposing the data with the merger. So the merger is very, I think, straightforward. It's also known as an absert. So let's take an example when we're writing some cities to our Delta table and we made a mistake. We wanted to have only French cities and we inserted by mistake San Francisco. So we removed it from the initial data set that we are loading. And if we do nothing, if we just do a simple insert, we are going to have duplicated rows, even worse with the same IDs and different city, different region. So it's quite catastrophic. Not only for you, but also for your customers. So whenever you will do a join with a duplicated data set, you will generate duplicates as well. So think of your customers. The same for the display field here for your business users. They will see the duplicated numbers or the same rows many times. They will not understand things, I think. So it's pretty confusing as well for them. And to avoid these kind of issues, there is this simple operation, which is the merge, where you define your merge data set, which is here the countries alias new data frame. You define your merge condition, so the ID column, and later you define the behavior. So here we are update or insert. We are not dealing with delays because the data set is incremental. So if you apply delays, you will probably delete wrong rows or empty your table even. And this is one, there are some things to remember, that your merge condition must be immutable in the sense of you cannot change the ID for the same row. So if you want to match them, obviously it must remain the same. And it can be also a computationally expensive operation. So that's something I had not pleasure, but it was hard learning from Spark 3.5, I think, when the merge didn't do any kind of predicate patch down. It was like scanning the whole table. It was quite a nightmare. Just we need to enable the Photon engine to handle this issue and leverage this dynamic file pruning feature on Databricks for that. So be aware of that as well for any of these operations and test it before if it fits to your needs. Because there is also delays, as I said. If you don't have the full data load each time, you will need to manage delays separately. And as There is also an alternative approach if the merge is quite expensive, or you cannot guarantee immutable condition. There is another pattern which is called the fast metadata cleaner, which generally leverages the partitions boundary. So, for example, you're running a daily job that writes data to a daily partition, and before writing each daily partition, you just do a simple truncate, and later you do a simple insert. So there is no kind of heavy computation, heavy joins or shuffle involved at all. But of course, as any patterns in the book and also in this session, it has some trade-offs. So you will need to choose which ones you are ready to accept. And we are going closely to the last pattern, so the metadata decorator. This is the one that will give you some additional context about generated data. Here I'm printing user metadata added in my test, so I just wanted to illustrate possible scenario. You may imagine having a GitHub issues with user requests to insert some records, to generate some records. You could possibly link them in the user metadata on your commit logs and give you some more information from why these records exist in the table. So it's very helpful to understand the root causes, like spotting different job versions, different deployment methods as well, whether it's reprocessing, backfilling, original load, or maybe whether you had to retry your batch workflow many times. It can also give you some hints. And there are two ways to configure it in Delta Lake, either at a Spark session level, where all the writers will inherit this configuration for their operations in case you are doing some fan-out writing. Or you can also define this once per writer with the same user metadata property. And yeah, I think that probably you will always use the second one with the writer because it's more specific to the data set you generate, unless you generate the same data set twice. But I think it's more rare than defining different flavors of a data set to write. There is one point to watch out currently also. The user metadata is per commit, it's not per row, it's not per any kind of thing you can imagine. It's per commit. So if you do some housekeeping operation like optimize, obviously it will create a new commit, your metadata will disappear. So in that case, if you do worry of having this metadata close to your records, to your rows in an immutable way, there is an alternative pattern which is called the wrapper that is more a database decorator that you can imagine as a struct column or even a separate table that you join with batch number or anything which is deterministic and comes from your batch job. And finally, the constraints enforcer. So the constraint enforcer is here to guarantee the data you're writing is correct. So you had this audit step, but of course, you define these rules by yourself. You can forget things. You can maybe misspell the function or UDF. You can make mistakes. So this is an additional layer of security to your data. And Delta Lake has a pretty good coverage for the constraint supports, like starting with the type constraints. You obviously define the types, it's structured, so that's awesome. You can define the nullability constraints, like to expect each column or a column to have a value. You can also define some expressions, which is pretty great too, because you can, for example, accept only uppercase letters and verify whether your city is equal to upper city. And you can also, if I'm not mistaken, do some cross checks. So reference other columns in your validation expressions. So it can turn really into some kind of powerful tool. And finally, there is integrity constraint. It's declarative. So semantically, your SQL will work, but under the hood, it will not be enforced. So they won't be any reference integrity checks like in MySQL or PostgreSQL. So that's why I put these two check marks, wrong and correct, in the last column for this part. And under the hood, there is a few things to know. So The validation is executed for each row you write, and it fails at the first encountered error. So it means that, for example, you are writing 100 rows in 10 files, and only the 100th row is wrong. You will generate 9 files that will be orphan files, and that's, by the way, important to run vacuums or use the predictive optimization. And it can also be quite annoying to you if you are just using this constraint enforcer, because I gave you an example of one failing row, but imagine a scale of 10 or 1,000 when you have many rows that fail for different constraints, and you will have to deploy your job test many times if what's wrong. So that's why it's also good to combine this with the audit write, audit publish pattern, and not do it separately. And there is this trade-off for that. You can use both. That would be my recommendation, just to be sure that you are generating good things, and you can also operationalize it daily. But if you have to choose, you need to choose between having a gatekeeper, so a delta lake constraint that they will say, no, this commit is not correct because of this row. And you can also have, or will have, the quarantine, where you will allow some flexibility, some imperfections to your dataset. Your consumers might not be seeing the full picture. They might be seeing only half of the dataset, and another half few days later once you fix the data quality issues, for example. And I think we are heading to the end. So thank you very much for your attention, and over to you, Robert.
Yeah, awesome. Thank you. So lots of interesting stuff to choose from. There's a couple of things I found interesting, and I'd love to get your opinion on. Let's maybe start in the beginning, earlier. So one thing that traditionally sparks a lot of interests among listeners is petitioning, right? So you mentioned petitioning, and petitioning sounds quite easy, but isn't. And what do I mean by isn't? So on one hand, here you mentioned petitioning that you might align with kind of how your data materializes, which may or may not align with how you query data, right? And then you also mentioned that there is new patterns, new technologies, specifically stuff like predictive optimization. And ultimately, the thing you're going to be judged on is how you expose the data, right? So in the beginning, you said that exactly right. So, I mean, it might be that the data ingestion is most fun, but the thing that you'll be judged on is how good is the quality of your data and how good is the experience for your end users. So kind of with these patterns, do you see that petitioning is still kind of the way to go, or fairly straightforward to apply? Or do you find that sometimes, well, you may have to swallow the pill, kind of that you can't work across petitioning boundaries because predictive optimization doesn't guarantee to you what the petition boundaries are, right? It does so dynamically. So do you have a preference? Do you have a preference kind of which way to go by now, or any opinions on that?
I think I would split it into two parts, like build part by engineers, or really having this partition separation when you're doing some time boundary based processing, like every hour, every day. It's easier, but yeah, it kind of enforces other teams to do the same or almost the same. You cannot choose other partitions, for example. So that may be a blocker, but from my experience, there's this time-based processing is quite popular. And there is another part which is the user facing, where you cannot predict the query patterns. And here I would rather prefer to start with liquid clustering or much more flexible approach, and do not enforce end consumers, and to use something I'm comfortable with at the engineering level.
Yeah. So in my previous life, I worked at a large manufacturing company, so a lot of IoT use cases. And this was sort of an interesting pattern, something that we saw, and maybe that's a pain you felt in the past as well. So time-based generation usually, generates data as time progresses, right? But always gives you a horizontal slice of your data. Well, I called it a horizontal slice back then. But what I mean by that is you may have thousands of IoT sensors in your site, and then you bucket them by day, what have you. Something that very rarely happens is that an end user says, give me the data for all the sensors for an hour. Usually in the analytics case, you have, okay, I have this handful of sensors that I'm interested in, and I want to see some significant history for this, right? Maybe a couple of weeks, maybe a couple of months, depending on the dynamics. And this was really a challenging issue, because you don't want to replicate all of this data, optimize it for query, but it's literally scanning 2 files or scanning like 1,000 files, depending on kind of the size that you ingest. Did you see some of those trade-offs as well in your life, or address them?
I'm not sure if I'm getting this correctly, but yeah, for me,
just to rephrase, I don't know. You have sensor ABC, right?
Yeah.
And if I do partition by day or by hour, like on a time axis, then I always have a bucket 1 hour with A, B, and C in there.
Yeah.
Usually in the manufacturing world, in the IoT world at least, which is my background, so my view on this is biased, of course. I wouldn't say, show me all the sensor data for a thin time slice, which is how the data is structured in that sense. But the usual query is orthogonal, is show me the data for very few sensors for a long period of time. Especially if you analyze trends, stuff like this, you usually don't want to see everything. Like, same for products, right? You seldom you say, show me sales for all products we have within the last hour. Usually you're asking something like, okay, what's the sales for this product over the last month, over the last week? So it's kind of in time-based, often orthogonal, how you query something versus how you receive the data.
Yeah.
If that makes sense.
Yes, I missed the analytics part, because it's just ad hoc querying on top of the data set engineers would use to generate some gold layer like data marts or stuff like that.
Yeah.
So that's the question, whether it's simple for you as an engineer or the others. When you use liquid clustering at this level, it'd be probably harder to do some delays. Like, you will have to do hard delays with dilation vectors. It will be more compute intensive, versus where you're using partitions, you do some truncating, validates all the files in the partition, and it's super easy and easy for you, but hard for the others. So there's always this trade-off where to use it, and who will use the data set more often.
Absolutely. We do have a question in the chat. It's a bit unrelated, so I'll postpone it for a bit. But Rudy, we'll get to your question in a little bit. It's .NET related, so I'll defer that. But I can say something to this. You mentioned state, right? And one thing I'd be curious about, the state, the activities table that you track, right? So what do I still need to do in terms of processing my stream? 2 questions. Is that in and of itself something that can grow considerably large? And especially for the in-memory case, would you guard this kind of if you run the risk of the job potentially crashing? Right, so can you recover this in-memory state? Because it's kind of on top of just the checkpoints, right? So the checkpointing is something that is persisted, but the, let's say, processing state, as you mentioned it, if you do sort of the in-memory piece, is this something where you need to be sure that you're stable in your operating, so that your job kind of doesn't crash, because otherwise you lost your state.
Well, you will not lose the state because it will be checkpointed in the end of each microbatch, unless it fails in the first microbatch. So in that case, you will have nothing. But if it fails, you will be still able to recover. And I think that because of this shuffle partition constraints, yeah, you can always scale the cluster, have more executors, allocate more memory per executor to handle better this extra load. Or otherwise use this transform with state with the initial state flag and do some state migration before restarting the job after the failure. But yeah, it's challenging. So that's why I say that it's always a kind of trade-off. You don't have a lot of code to write, but it's much harder to operationalize versus when you store it as an additional delta table. You have to write the join logic, but on the other hand, it's stateless, so you can even use auto-scaling, and yeah, it will add up pretty easily.
Yeah, I mean, you said it. Streaming, I always found it interesting. Streaming makes a lot of things easier, but it's also very hard to get it up and running. We have a question from Chicago. To be honest, I don't exactly know the abbreviations, but Bartosz, hopefully you do. Can we scale Delta to ODS? Do you know what ODS is?
Open data stack? No, I have no idea.
I'm not sure. I don't know, Muhammad. If you're listening, feel free to post in the chat what ODS is. Sorry about that. All right. As we wait for this, there's a couple of other interesting things we can talk about. One thing I found interesting, and that's a challenge kind of throughout, if you look at, okay, operational data store, that's ODS. So can we scale Delta to an ODS, operational data store? I'm also not entirely sure. I mean, supposedly we both are from the from the data domain.
It's like to have the transaction and, for example, web services writing delta commits or things like that.
Yeah, I'm not sure. So, I mean, operational sometimes reads as transactional. I don't know if there is a synonym for that, and there I can just say kind of transactional. Having very tiny batches and very tiny updates is a challenge with Delta. So if your workload is kind of point update heavy and not so much batch update heavy, Delta or any open table format for that matter might not be the best option for you. In a way, deletion vectors kind of try to mitigate some of this, but it's still not, okay, this is for transactional workloads. I don't know if this answered the question.
Yeah, in that case, your workload will be more like housekeeping heavy, like doing the checkpointing for compacting the logs or doing the vacuums for old files. So yeah.
Yeah. So there is another question of alerting. So you mentioned the pattern of writing data into a quarantine table, right? And how would you realize, so on Databricks itself, there is alerting functionality, data quality checks that go into that domain, but kind of from your perspective, how would you implement alerting for the quarantine data? And you mentioned some of this before, right? So in general, where you want to observe trends in your table, how much data lands, I don't know, do we have outliers and this kind of stuff? But how would you look into the alerting aspect of it when you observe drift?
I mean, alerting in terms of notifying users about something going wrong, right?
Yes.
So different things. It can be a new workflow, a new task in the workflow to verify whether there is something new in the table that may send a notification, or can even fail if you want to fail the workflow to see it more, to see it more exactly in the interface. You can also use the dataset observable in Spark, where is a kind of wrapper around the data frame. You can register some stats, simple stats like counts or other things, so that you avoid doing two writing operations on the same dataset. And in that case, you just do the count on the quarantine dataset, and whether it's higher than 0, you send something to notification service, SNS or SQS on AWS, those kind of things. Or leverage the native features as well. Yeah. They will help to facilitate life.
Yeah. Quick question. So since Delta and open table formats support versioning on the table, would you also say you can just kind of check the version and in a kind of very, very simple job, just give me the version, and then alert on when the version updates on the table?
Yeah, just to verify the operation, whether it's not, there's maybe something, I think the data change attribute in the commit action, or either in the operation filter out all the vacuums or other things.
Yeah, we have some clarification on the operational data store, operational data source. So it's transactional data in real time of snapshots. The transactional word is something where you really want to be careful in the Delta world. So you can get, well, actually, Bartosz, I'll let you answer that. So sorry about that. But
no, please go ahead. I'm also learning from you, so yeah. I'll be complete later.
In general, when you hear transactional, you think Postgres, you think many kind of point updates, single record kind of updates, and this usually leads to high fragmentation in files, fragmentation in the sense of you might have deletion vectors, or you might have to read a bunch of data. So write amplification is a real challenge for those kind of things, right? So let's imagine you land a file that's, I don't know, 100 megabytes or a gigabyte, and then you want to update a single row. Write amplification would mean you need to rewrite a gigabyte of data to update a single record. So there's ways around this, right? And there's ways how the community and the technology optimized for some of these cases. But when you hear transactional, let's say beware. And as a Databricks employee, I would say have a look at Lakebase, or sort of a transactional data store that's maybe more suited for this. On the other hand, if you do large scans, if you want to do analytics on a bunch of this data, the inverse is true, right? You don't want to do full table scans in Postgres all the time. That's also not healthy and not what this is kind of built for.
Yeah, so
right?
It's about the difference in transactional approach. I think Delta Lake is more, from Spark perspective, you have a distributed writer, and historically, whenever a job was failing, it was leaving files behind for the task that succeeded. And other consumers might consider those files as valid ones for processing. While here with Delta Lake, you ignore those files in detecting whether you should process the data or not, because there is another file that is created in the end, which is the commit log. And only when the commit log is created, the reader acknowledges those files as valid and fully available for processing. So I think this is a different perception from data and kind of transactional web API, web services world.
Yeah, absolutely. Since you mentioned web services, there is a question: can we use Delta Lake in a Spring Boot project? I don't know how deep you are in API development, but do you want to field that question?
Spark can run with local masters, so ultimately you can write Delta Lake table from a Spring Boot. But whether it's worth it or not, I don't know. I think will depend on the volume and the purpose, because if it's too quick as PostgreSQL or MySQL, just send indexes, it should work better, I think. Whether as you said, if you have big data volumes to analyze in an ad hoc manner, that may be better to consider Delta Lake.
Yeah. So maybe adding a little bit of context on it, it depends on what you want to do, right? So a Spring Boot application, you probably don't want to kind of equip it with gigabytes and gigabytes and gigabytes of RAM, which is what you would need to do if you want to process even in single node mode kind of significant amounts of data. However, there's other use cases where you may be only interested in metadata of a Delta table, stuff like this. And there is some good news. There is the Delta kernel project, which is kind of a Spark-free, lightweight way to interact with Delta tables. So if you're not processing huge amounts of data and are just kind of interested in interacting with a table, Delta kernel might be a good thing. The other thing that I would personally recommend is Spark Connect. So if you do have something data heavy, offload the actual processing to somewhere else and just send the results over the wire, so you don't blow up your service unnecessarily. And for this, Spark Connect is a great option, right? So you can kind of write your query, reason, have your business logic live in your service, and just send that off to something that then does the execution, so the heavy lifting, so you don't need to allocate an unreasonable amount of resources within your service and have that sort of separate, right? So hopefully that answers the question. But I mean, generally it's all Java. Spring Boot is Java. Spark, you can run in Java. So yes, you can do a lot of processing. Maybe I'll jump onto the question that we had earlier around .NET. Let me fish out that question really quick, because it's somewhat related, since I already mentioned Delta kernel. So there is Delta.NET. It's a very interesting project by another great contributor in the community. It actually leverages, and people might be surprised, but I'm a huge Rust fan. So it leverages Delta kernel RS and Delta RS to do an integration. I don't think there is an explicit roadmap for the project, but there is definitely interest in kind of maintaining it. So if there is interest in certain features in getting stuff released, I'd recommend opening an issue, or joining the Delta Slack channel, or joining Delta Slack and asking the questions there. And the author of the .NET project, who also donated it, is active there. I think his GitHub handle is Mighty Shazam. I think it is. But yeah. So, and this is a project that's being used productively by certain companies. But yeah. So we have some more question. One is, what's the best way for large data frame writes in Delta? Do you have an opinion on that? You mentioned shuffles before. Ultimately, is there things you learned along the way that makes kind of writing large data sets a bit easier?
Now I will stick to these adaptive query engine optimizations for all the shuffle issues. I usually try to avoid as much as possible big data sets, because if it fails, it typically fails after 2 hours or 3 hours, and your whole day is like broken. So I try to at least split it into reasonable size so that I get the feedback as early as possible. And like with this available now trigger, you can do it also on top of static data sets by defining the boundaries. Like if you have files, you can define max files per trigger. So you can have 100 files, you set it to 10, and each time you run a batch, but it takes 10 files each time. So I will try to approach this big problem that way.
Yeah, I agree. Try to chunk your work in some way, shape, or form so that you can make some progress. And as you say, don't fail. Errors usually compound. And exactly as you say, Bartosz, I forgot the name of the law. There is this kind of law that kind of anything that can go wrong will go wrong, and kind of at the most inconvenient time.
I heard it too.
Yes. There's a question that may be interesting. So one of the listeners is trying to build a data quality framework to handle large 20 terabyte, so really, really large Oracle data dumps, and wants to build sort of a data quality framework on top of that. You mentioned some approaches for data quality earlier. Yes. First of all, yes, don't replicate this in another relational database. If you want to process this kind of amount of data, this is what Delta is built for. But Bartosz, go ahead with the quality aspect of it.
I would recommend avoiding building a data quality framework, maybe extending the ones I quoted previously. Without open source, you can create an issue, you can contribute. It will benefit to all the community, and you will not start from scratch. You will not make the mistakes others already did and solved. So yeah, just try them out.
Yeah, I can just second that. Data quality can be a rabbit hole. Digging into that can be a fun little exercise, but if you want to get something in production, use something that's out there. I think you mentioned Spark expectations and DXQ, right? Both of them have seen a lot of mileage in production environments, work really well with Delta Lake and the Spark ecosystem, and are very feature rich and have kind of a higher level APIs that make your life a lot easier. Yes. So one fun question. one fun question I wanted to ask. We talked about, since we are in the data quality world, and you mentioned some of these checks that we can define on the table. One good piece of advice you gave is try to use deterministic functions. So no, I don't know, now or random number or stuff like this shouldn't be part of your data quality checks. They should be deterministic, ideally. How do you feel about UDFs in data quality checks?
They are not deterministic from Spark for Catalyst Engine, that's for sure, but it depends how they are implemented. Yeah. If it's like tricky concatenation function that combines multiple rows always in the same way, is deterministic, but yeah. I don't know if it was the sense of your question, but there is something hidden in your mind.
Well, I mean, I kind of wanted to open the gates also for a word of caution around this, and we mentioned Delta kernel a couple of times. These data quality features do have a couple of challenges. In principle, they work really, really well until they don't. What do I mean by until they don't? So implicitly right now, they assume a Spark dialect for the SQL that you write in those constraints. And this has been quite successful for a time. However, with Delta kernel, and we were asked about kind of the .NET engine, which right now would leverage something like Data Fusion, which ultimately boils down to a Postgres dialect. You can use different dialects as well, right? So, but if you write data constraints, my personal recommendation would be try to stick to ANSI SQL as much as possible, kind of the shared or a very widely adopted shared common denominator in SQL, and try to avoid anything that's kind of a specific flavor as much as possible. I don't know, Bartosz, do you have experiences in this sort of things?
So someday in the past, I had to deal with recursive CT when it was not available on Databricks, and I had to implement it on my own with SparkJob.
Recursive CTs within data quality checks, yes?
No, this one was not for quality checks. It was like for the generated data set to validate.
Yeah.
But I agree mostly on this ANSI part that it simplifies a lot of many people. And the day you will do, or your colleague will do the migration to other stuff, database,
Yeah. So there is another question around kind of the data quality, kind of a follow-up. So DQX being native to Databricks, I don't know, is DQX tied to Databricks?
It was part of Databricks Labs, I think.
It was part of Databricks Labs, but I think you can use it with kind of Spark, and it's not tied to any Databricks features, is it?
No, I think it's Spark, backed by Spark. Like
and
Spark expectations, the same
thing, right? I think you can use this in vanilla Spark. Again, executing Spark within a Spring Boot application you need a very big Spring Boot container, and you're kind of running a single node instance of Spark within an API. I'd be cautious, but there's a lot more to say about this, right? So I mean, we can't cover everything here, but yeah, it's not a lock into Databricks. It's Spark, but yeah, just beware. Putting
There's
this
always the question: you prefer to lock something to something, or you prefer to spend 2 years on building things that doesn't look to anything?
Yeah. All right. I think we're about at time. Thank you so much, Bartosz. Thanks everyone for all the great questions out there. So pain points in data engineering seems to be something that resonates with the community. So everybody experienced that. If you want to get more of Bartosz's insights, feel free to visit waitingforcode.com. Yeah, there you can see more of his thoughts and impressions out there. Bartosz, thanks for sharing your insights, sharing your experiences. Thanks. Thanks for being here. And I don't know. Do you want to say a couple of words, say goodbye?
Thank you, Robert, for having me here, and see you next time.